needs to measure how well their Bedrock agent's responses align with ground truth answers from subject matter experts. Which evaluation metric is most appropriate? Option A, use Bedrock model evaluations with correctness and completeness metrics that compare responses to reference answers. B, calculate cosine similarity between response embeddings and reference answer embeddings. C, measure response latency as a proxy for response quality. D, count keyword overlap between responses and reference answers. The correct answer is A. This is a straightforward evaluation question, and the phrase ground truth answers from subject matter experts is the giveaway. Amazon Bedrock model evaluations provides exactly that with metrics like correctness, which is the response accurate relative to the ground truth, and completeness, does it cover the key points in the ground truth. This approach is designed to handle paraphrasing. The answer does not have to match word for word to be judged correctly. That is why A is the correct answer. Why are the other answers incorrect? Option B uses embedding cosine similarity. Similarity is not correctness. Two answers can be semantically similar while one is subtly wrong. Option C is incorrect because it uses latency. Latency is an operational metric. It tells you nothing about correctness. Option D is incorrect because it uses keyword overlap. Keyword overlap fails the moment the model paraphrases, and it also misses subtle factual errors. For ground truth alignment, use Bedrock model evaluations with correctness and completeness. The correct answer is A. A company wants to validate that data flowing into their RAG pipeline meets quality requirements, including proper schema formatting and no missing required fields. Which approach provides automated validation with minimal custom code? Here are answer options. Option A, AWS Lambda functions with custom validation logic. Option B, AWS Glue Data Quality with rule sets that publish validation metrics to CloudWatch. Option C, Amazon Macie for data classification and validation. Option D, Amazon SageMaker Data Wrangler for interactive data profiling. The correct answer is B. This question is asking for three things: automated validation, schema and completeness checks, and minimal custom code. That should push you toward a managed declarative quality service. AWS Glue Data Quality is purpose-built for this. You define rule sets like require columns exist, no nulls in required fields, expected data types, and basic constraints and expressions. Glue evaluates the data against the rules and publishes metrics to CloudWatch so you can monitor and alert when quality degrades. That's why B is the correct answer. Why are the other answers incorrect? Option A is custom Lambda logic. That is the opposite of minimal custom code. You have to build and maintain validation rules yourself. Option C is Macie. Macie is for sensitive data discovery and classification, not schema validation and completeness checks. Option D is incorrect because option D offers Data Wrangler. Data Wrangler is interactive and development oriented. It is not designed for automated, continuous validation in production pipelines. For automated data quality, declarative rules plus CloudWatch metrics equals Glue Data Quality. The correct answer is B. The company wants their Bedrock agents to call tools with consistent interfaces that can be reused across different agent frameworks. Which integration pattern best supports this goal? Here are your answer choices. Option A, create REST APIs for each tool and have agents call them directly. Option B, expose tools through Model Context Protocol, MCP servers, accessible via Agent Core Gateway. Option C, implement each tool as a Bedrock action group backed by Lambda. And D, build custom tool wrappers in each agent framework. The correct answer is B. This question is about tool portability. They want consistent interfaces. They also want reuse across different agent frameworks. That immediately rules out framework-specific tool wiring. MCP, the Model Context Protocol, is specifically designed to standardize how agents discover and call tools. So you can expose a tool once through an MCP server, and then multiple frameworks can use it without rewriting integrations. Agent Core Gateway is the managed AWS piece that makes MCP practical in real systems. That's why the correct answer is B. Why are the other answers incorrect? Option A uses REST APIs directly. REST is not a standardized agent tool protocol. Each framework still has to implement its own tool calling patterns, auth handling, and response parsing. Option C is incorrect because it uses Bedrock action groups. Action groups are specific to Bedrock agents. That does not satisfy the requirement of reuse across different frameworks. Option D builds custom wrappers per framework. That is exactly what the question is trying to avoid. It creates duplicated integration work and ongoing maintenance burden. For cross-framework tool reuse, if you need write once, use everywhere, think MCP. The correct answer is B. Company's compliance team requires the ability to review all Bedrock API calls, including which IAM principals made them. Which service provides this audit trail? Option A, AWS Config for resource change tracking. Option B, AWS CloudTrail with Bedrock API event logging. Option C, Amazon Bedrock model invocation logging. Option D, Amazon CloudWatch logs with custom metrics. The correct answer is B. This is a classic audit and compliance question. The requirement is very specific. Review all Bedrock API calls, see which IAM principal made each call. That immediately tells you this is about AWS API level auditing, not application logs or metrics. AWS CloudTrail is the service that records who made the API call, when it happened, from where, and which service and operation was invoked. For Bedrock, CloudTrail captures both control plane operations and runtime API calls, along with the IAM user or role that made them. That is exactly what compliance teams need. That is why B is the correct answer. Let's talk about why the other answers are incorrect. Option A uses AWS config. Config tracks how resources change over time. It does not log API calls or user activity. Option C uses model invocation logging. Invocation logging focuses on prompts and responses, not identity. It does not tell you who made the call. Option D uses CloudWatch logs. CloudWatch can store logs, but it does not automatically capture API calls or IAM principles unless you build everything yourself. For compliance auditing, if you need to know who called what API, think CloudTrail. The correct answer is B. Companies' OpenSearch vector index has millions of small shards causing high query latency. Which optimization will most improve semantic search performance? Option A, enable cross-cluster search to distribute queries across multiple clusters. Option B, increase the refresh interval to reduce indexing overhead. Option C, consolidate into fewer larger shards optimized for vector search, 30 to 50 gigabytes per shard. And D, add more replica shards to distribute query load. The correct answer is C. This is a vector search performance question, and the key problem is right in the question: millions of small shards. For vector search, that is a performance killer. Each shard runs its own approximate nearest neighbor search, and then results have to be coordinated. When you have too many small shards, coordination overhead dominates query latency. Best practice for OpenSearch vector workflow is fewer, larger shards, typically in the 30 to 50 gigabyte range. That reduces coordination overhead, improves cache locality, and make HNSW graph transversal much more efficient. That is why C is the correct answer. Here's why the other options do not solve the root problem. Option A adds cross-cluster search. That increases coordination complexity instead of reducing it. Option B changes refresh interval. Refresh interval affects indexing throughput, not vector query latency. Option D adds replicas. Replicas help with read throughput, but they do not reduce the cost of coordinating across too many shards. For OpenSearch vector performance, too many shards hurt. Fewer, larger shards win. The correct answer is C. Team suspects their RAG system is retrieving passages that are semantically similar but factually out of date. Which investigation approach is most appropriate? A, monitor token usage patterns to identify if outdated documents have different content lengths. B, analyze retrieval results to verify metadata filtering is correctly excluding outdated documents. Option C, compare Rouge scores between old and new document versions. Option D, run RAG evaluation jobs with reference contexts that include document timestamps. The correct answer is B. This question is testing whether you understand where freshness problems live in a RAG system. If documents are semantically relevant but factually outdated, the issue is almost always in retrieval configuration, not generation. Specifically, it points to missing metadata, incorrect metadata filters, or filters not being applied correctly at query time. So the right investigation is to look directly at the retrieval results and verify that metadata-based filtering is actually excluding outdated documents. That is exactly what option B describes, and that is why B is the correct answer. Why are the other answers incorrect? Option A looks at token usage. Token count has nothing to do with document freshness. Option C uses Rouge scores. Rouge compares text similarity, not retrieval behavior. Option D runs RAG evaluations. Evaluations tell you what happened, not why outdated documents were retrieved. For outdated data issues, if the content is old but relevant, check retrieval filters first. The correct answer is B. The company wants employees to ask questions about documents stored in Amazon S3, SharePoint, and Salesforce. They use per user access control based on existing corporate permissions. Which solution provides this capability with minimal development? A, use Amazon Q Business with data connectors and IAM Identity Center integration. B, deploy separate Bedrock knowledge bases for each data source and manual access control. Option C, build a custom RAG application with Bedrock knowledge bases and implement authorization in Lambda. D, use Amazon Kendra with custom authorizers for each data source. The correct answer is A. This is an enterprise document Q&A question. The requirements are multiple enterprise data sources, per user access control, respect existing permissions, minimal development effort. That is exactly what Amazon Q Business is designed to do. Q Business has managed connectors for S3, SharePoint, Salesforce, and more. Q Business integrates with IAM Identity Center and automatically respects source system permissions. So users only get answers from documents they are allowed to see. That's why A is the correct answer. Here's why the other answer options are wrong. Option B creates multiple knowledge bases. That adds operational complexity and still does not automatically enforce source permissions. Option C builds custom authorization. That is a high development effort and easy to get wrong. Option D uses Kendra with custom authorizers. Kendra can do this, but it requires more custom work than Q Business for the same use case. For enterprise GenAI with permissions, if you want minimal code and built-in ACLs, use Q Business. The correct answer is A. The company wants to build an agentic workflow that breaks complex questions into explicit reasoning steps with conditional branching. They need audible traces of decision points. Which approach best supports this requirement? Here are your answer choices. Option A, implement a React-style workflow using AWS step functions where each state calls Bedrock for reasoning steps. Option B, use a single Bedrock agent with detailed system prompts describing the reasoning process. C, use Bedrock flows to define the reasoning pipeline. D, create multiple Lambda functions that chain together with custom logic. The correct answer is A. This question is really about listening. audible reasoning. They want explicit reasoning steps, conditional branching, and clear, reviewable decision points that immediately pushes you towards explicit orchestration, not hidden reasoning inside a single model call. AWS Step Function gives you visible state transitions, choice states for branching, execution history for auditing, and clean separation between reasoning and orchestration. A React style pattern maps perfectly to step function states. That is why A is the correct answer. Why are the other answers incorrect? Option B hides reasoning inside the model. There are no explicit decision points to audit. Option C uses Bedrock flows. Flows are great for simple pipelines, but they do not provide the same level of auditable conditional logic. Option D chains lambdas manually. That recreates step functions with more code and less visibility. For auditable agentic workflows, if reasoning must be visible, orchestrated explicitly. The correct answer is A.